I'm Mitul Tiwari. Today I'm going to talk about AI agents and TapeAgents framework that I worked on at ServiceNow. Uh, so thanks, Daniel, for nice introduction. This is just a bit about myself. I won't go in detail. Daniel already covered. Currently, I am co-founder CTO of Numos AI and focused on building adaptive AI agents. So here are some challenges with enterprise AI agents. LLMs, as you know the language, but they don't have enterprise knowledge. And at enterprises, cost accuracy trade-offs are critical for wider usage. Agents with larger LLMs, language models, are more accurate, but they are costlier and expensive. And also enterprise adaptation is must for language models for cost accuracy trade-off. So how do we adopt AI agents for a particular domain or enterprises? So that's what I would like to cover in this talk today. So how many of you have built an AI agent or familiar with the internals of AI agents? Okay, few. So let me just introduce some concepts and building blocks of AI agents. So at high level, you can think about LLMs with tools. People are calling AI agents. And basically, there is input. LLMs may respond directly to the user's input or may take some actions invoking some tools and then respond back to the users. An example that MCP has become very popular. There are all kinds of MCP servers people are posting. You can integrate those MCP servers with Anthropic's Claude app, and basically your Claude app, in some sense, becomes agentic and an AI agent. So here are some of the components of AI agents. So one involves planning. Basically, given a goal, break it down into series of actions. Tool use, translating those actions into which tool may complete those actions and may invoke external APIs or execute some code, invoke maybe calculator, things like that. And then have some sort of short-term or long-term memory. There was a previous talk about RAG, which is kind of providing context and prompts, and long-term in some sense retaining some memory from previous interaction and recalling that. Benefits of AI agents are now quite well known. That's why they are becoming popular. They can increase productivity, decrease cost, help with decision making, can work 24/7. For example, customer service AI agents, and they can analyze vast amount of data, and so that like all of us can focus on higher value tasks. So a typical pattern for agents are what they call react pattern, basically reasoning and action pattern. So like basically when an user input comes, LLM decide to take certain action or should like decide to respond to user, and when taking action, which tool to use, and basically function calling, and when tool responds, go back to LLM to decide whether to continue calling more tools or respond to the user. So this is a typical reason action pattern, and think about a loop in some sense where user input can invoke various kind of tools, and tools produce observation, and observation comes back to LLM to decide whether keep invoking more tools or construct a response to get back to the user. And a couple of years back, this React paper came out that made this pattern very popular, especially in context of, in some sense, some sort of search tool and RAG, where like just reasoning like chain of thought prompt reasoning doesn't work, just invoking web search kind of tools doesn't work, but if you combine thoughts and actions, things work well. So that's kind of a very popular React pattern. And let me talk briefly about various agent building frameworks. So there is a plethora of agent building frameworks in last couple of years. In some sense, LangChain was one of the first one that came out in late 22. And since then, there's like every few weeks, we are seeing an agentic framework announcements, AutoGPT, AutoGen, Crew AI came out in 23. Then like LangGraph from LangChain, Llama Index, expanded into agent building architecture, came out early last year, and then TapeAgents that I worked on at ServiceNow, we open sourced it last October, and since then there's Anthropic MCP came out last November, recently OpenAI Agent Development Kit, and Google's Agent Development Kit came out in last couple of months. So there's a like plethora of agentic frameworks are coming out. Let me just give a brief overview of three agentic frameworks before diving into TapeAgents. So how many of you know about MCP or Model Context Protocol or built MCP integrated? So yeah, it seems most of you know about MCP. It has become a very popular open standard for integrating tools into LLM app, right, like Claude app, and basically it's an integration architecture in some sense where you can create MCP servers around tools and integrate that with MCP clients, and a lot of client applications like Claude app or Cursor are supporting like basically have MCP clients that can support many different kind of MCP server. And in some sense, it simplifies tool integration, and also a lot of different model providers like Anthropic was the first one, but now Google and OpenAI are also supporting MCP protocol, and basically instead of integrating your tools individually with each model, you can have integration through MCP. So it simplifies tools integration while using different models. LangChain is another popular agentic framework. In some sense, it's one of the first one that represents agents as graphs. And basically, you can define a structure of agent, for example, where to begin with, like an LLM agent that and tools, action, nodes, and basically specify edges between them. You can specify edges between them and create an agent using graphical way. And you can have like complex agentic system in some sense through these creating these graph and manage dependencies between tools and various components. And basically, it helps you modularize the structure. The tricky part is like sort of it has some rigidity in some sense. Like if you want to now somehow like you build the agent and your agent is not working well, how do you debug it, adapt it? They have been launching new things like Langsmith to provide some sort of traceability, but overall adaptation of agents is not trivial. So on the other hand, DSPy is another framework. It started as an academic project. How many of you have heard of DSPy? Okay, a lot of you. So basically, it's more like an prompt optimization framework. It has like sort of three parts where You can specify like a signature, what should be the input-output requirements. You can specify different prompt techniques you want to use in terms of prompt optimization, like chain of thought or React prompts. And basically, there is an optimizer that optimizes the prompt, in some sense, changes the prompt based on the examples, training examples, and the accuracy metrics you have specified. So it's like sort of taking the other way in some sense, where you can write Python programs in their DSL, and basically it's geared towards optimizing prompts. The tricky part with DSPy is like sort of you're just optimizing the prompt, but if your LLM doesn't have knowledge or doesn't know how to act, it's very tricky to work with. So that's kind of a couple of different agentic framework to motivate TapeAgents framework. And here are some of the things I'll cover in the rest of my talk. Give an overview of TapeAgent, architecture of it, and show some benchmarks and comparison with other frameworks. So one big motivation for TapeAgents was cost accuracy trade-offs. As I talked about, you need high accuracy at a low cost for wider adoption of AI agents. And like basically, if you use larger language model, normally you get higher accuracy, but it comes at higher cost. Versus, let's say, if you use smaller language models like Llama 7B, then like basically it's more cost effective in terms of latency and serving cost, but normally they are not that accurate. So how can you improve their accuracy so that you get high quality AI agent at a low cost? Also, like LLM-driven AI agents are non-deterministic in some sense. Like LLMs are known to give different kind of output for the similar input, and sometimes because of that, LLM agents becomes little unpredictable, and they are hard to debug. If you have integrated the tools may respond differently at different times based on the current state of the agent. And so it's very hard to debug. Also, so basically the traceability is also hard in many of the frameworks. Many of the frameworks are introducing traceability, like Langsmith was introduced in LangChain last year that provides traceability, but the optimization is still missing in some sense. And so TapeAgent unifies both development of AI agents and continuous improvement. So TapeAgent basically is a framework that, as the name suggests, it's a simple concept called tape, which is a structured log that records every agent step. And basically, it allows basic agent development, debugging, as well as optimization, as I'll talk about later. And key benefits are around transparency, debuggability, and optimization. And this agent framework, there is a detailed report that was released, as well as this is an open source project on GitHub. You can check it out. So here are some of the benefits of TapeAgents. Basically, transparency and control. As you record all the actions and thoughts of LLM outputs, as well as observations from the tool use, the tape provides transparency and control. And basically, using the tape, you can resume the sessions from any point at the time, replay the sessions because your tool's output observations are recorded. You can replay the sessions, and basically, even if you are changing, let's say, LLM or prompt, you can reuse the observations from tool use from the past. and allows step-by-step agent behavior understanding and improves debugging. And also it allows data-driven optimization. So you can use the tape to optimize the prompt. You can use the tape to play around with different LLMs. You can use the tape to create training data to fine-tune a smaller language model. And I'll talk about distillation from a larger teacher model to a student model through tape reuse. And also it provides integration with reinforcement learning techniques for agent improvement. So Tape Agent is a framework built around a structured, granular, semantic level log called tape. And basically, tape consists of three kinds of recordings. One is thoughts that represent LLM reasoning, agent reasoning. It also has like actions, which basically how to interact with the environment in terms of different kind of tools, whether it is through APIs, RAG, code execution, or a web browser. And also it records all the observation that were like output of the environment or tool use. And so that's kind of the central, all the execution is tape driven, and that facilitate a lot of things. And basically, agent reads the tape and prompts the LLM to generate the next set of thoughts and actions. And once actions are recorded back, and both are recorded back in the tape, and actions are used to interact with the environment, and the output of environment observations are recorded back in the tape. And this flow continues until the given goal or task is completed. And so continuing on, there is like kind of an orchestrator that manages interaction with the agent, the tape, and the environment, and like sort of facilitate this synchronization. And also, there are various developer tools that can read the tape for various like sort of interruption or reuse, as well as evaluating and monitoring the agent. Also, it facilitates the optimization in the sense tape can be used to create training data for fine-tuning the LLM, and can be also used for prompt tuning, playing around with different LLMs, as well as RLHF. So let me walk through three example agents and like sort of how it can be structured in tape agent framework and like associated tapes in some sense. So the first example is a simple one, is a stock analysis agent. It has two tools in some sense. One is looking up stock ticker, as well as also doing searching the web for information about a company or ticker. And so this is an example tape for a run. So let's say, tell me about Vulcan in 3 sentences, where Vulcan is a company. And so first step is like sort of, so these are the thoughts produced by the LLMs in purple. Basically LLM produces based on the available tools, look for the stock ticker symbol for Vulcan, and the action or like sort of from the environment or the API call comes back with like VMC as the stock ticker symbol. That's also recorded in the tape, and further like sort of next series of actions is taken in terms of finding the stock value for stock ticker VMC, and those observations are also recorded. So this is kind of an simple example of stock analysis agent, and little bit more on tape agent execution model, like sort of basically so each the agents are represented by nodes. Each node has like kind of two methods: make prompt and generate steps. And so steps are either basically thoughts or actions, and thoughts are internal. Actions are something you take on the environment. And so like sort of this agentic loop in some sense creates a prompt for the LLM which generates thoughts or actions. If it is thought, this loop continues until LLM produces an action, and then action, like all these things are steps are recorded in the tape, and this loop stops when the last step produces is an action which goes into like basically environment to for tool use or take an action. So that's kind of this tape agent execution model. So that let me give another example of form filling agent. This is very common use case in enterprises, from like creating ticket or, for example, IT service catalog request. And the task is route user to the right form and fill that form interactively. So for example, let's say if you want to request a new laptop or reset password or AWS account request, you need to fill a form normally to get that request done. And we want to create a very high fidelity agent at a low cost. And with this approach, we were able to create GPT-4o level agents with using a fine-tuned Llama 8B model, so which was like 1/300th of the cost. And I'll talk more about this distillation of teacher-student model, where we used a large Llama model with different user agent in some sense to simulate user behavior and create different tapes or like dialogues which were used for fine-tuning a smaller Llama model. So a bit more about this teacher-student agent training, and this is kind of a mechanism to train cost-effective LLMs. And the teacher agent would use a much larger model like Llama 405B, and like a lot more nodes for more fine-grained control, and basically produce the tape, interact with user agents as well, and produce the tape which which are used to train a smaller student model. And there are simple mechanisms like take a tape and generate training data for training another model. So the reuse of tape is possible in this framework. And these are some of the results. And before going into the results, so, we defined this graded metric, which is grounded, basically reduced hallucination responsive, which is basically acknowledging what a user is saying, accurate, disciplined in terms of following what user is asking for, transparent in terms of what action agent is taking, and helpful in the sense moving towards accomplishing the goal. And in these, the metric, by training in this framework, as I talked about, we were able to train smaller Llama 8B model, which would perform at same level as GPT-4o, and even in some sense better than Llama 405B. So the cost comparison in terms of like the GPU usage, the fine-tuned smaller Llama model for the similar accuracy as 405B model would be like 1/300th of the cost and much more lower than GPT-4o. Again, this is like sort of a particular time around late fall last year. GPT-4o pricing may be changing over time, but the concept still stays in some sense. So let me give another example of agent. So this is third example, web agent. Think about as like sort of operator, OpenAI operator kind of web agent. Like how do you build it using TapeAgent framework? And so this is just a simple example. Let's say you want to book a flight from San Francisco to Seattle. You want to interact with web agent in natural language, and let's say it drives the browser to complete the task. And it involves, in some sense, like sort of this 3-node architecture in this implementation, which would like sort of reflection node, which would like figure out what actions to take in terms of the action space in browser are like sort of where to click, where to type, scroll, things like that. And like sort of it involves generating, let's say, Python and Playwright code to drive the browser, and then from the browser, collect the screenshot, set of marks, like sort of bounding boxes of various parts of the page, accessibility tree, HTML source, and basically all these observations are recorded in the tape and like sort of to take the next set of thoughts and action. So this is kind of how web agents can be created using TapeAgent framework. And this is just like web agents can address a lot of low-cost, low-volume tasks. And like sort of this is just a diagram showing like capability versus like cost effectiveness in some sense, like from how we traditionally built using API calls. RPAs are in some sense more capable. API agents have even more capability, and like web agents in some sense, which are possible now, are even more cost effective and more capable because not every web services have APIs. And like sort of we are in some sense somewhere here in timeline where like let's say in near future, if you can create tools that you need to accomplish tasks, will truly reach towards creating general purpose agents. And like sort of web agents, why web agents are like in flux of what's possible, what's still challenging is because of like HTML pages may be really long, require very long context window, and we are talking about multi-step process. So the context keep accumulating, multi-modality, as I talked about. If you like sort of normally user interact with the visual element, so it's not just text, and like there are various considerations like safety. Let's say for let's say the example I showed, like booking a flight, you don't want to book some random flights to random places or multiple flights, and basically building cost-effective web agents. So these are kind of 3 examples of various kind of agents you could build using TapeAgents, like stock analysis agent, form filling agent, and web agent. Let me continue, and I'll come back to, if time permits, I can walk through a Collab notebook. So here are some comparison with other agentic framework like LangChain, which offers very fine-grained control by creating nodes and graph but it's very hard to optimize if your AI agents are not performing well. DSPy provides prompt optimization, but it's very rigid in terms of using their DSL to create your application, and like it doesn't provide a lot of other things like resuming sessions or like sort of debuggability, and even like fine tuning the LLM. It doesn't go like very deep, versus TapeAgent provides a lot of these things in terms of data-driven optimization for prompts, the model, and a lot of dev functionality in terms of resuming the session, debuggability, and things like that. So that was like giving an overview of TapeAgents. Let me briefly talk about domain adaptation techniques. So I'm sure a lot of you are familiar with some of these techniques like prompt engineering, retrieval augmentation, supervised fine-tuning, and reinforcement learning. And so like there are, in some sense, two dimension. One is like what model needs to know. Prompt engineering and retrieval augmentation provides way of giving context to LLM, and supervised fine-tuning and reinforcement learning are LLM optimization techniques. So model learns how to take certain actions. So yeah, prompt tuning, there are some standard tuning approaches like sort of providing few examples or few short prompting. The other variations like chain of thought prompting, where you give like sort of specify the reasoning or like sort of the thought process to get to the final outcome. React is another prompting technique where you give reason and action as well. And basically, it enhances model's ability to follow through your prompt. Retrieval augmented generation, the previous talk went into great detail about RAG. Basically, it's about providing context or more data for LLM to take certain action or come up with an answer. In terms of fine tuning, there are like sort of supervised fine tuning approaches like LoRa, low rank adaptation, where instead of training all the parameters of the model, you just take small fraction of parameters, in some sense, particular layers in the model that you want to fine tune. So that like, let's say in most of LoRa fine tuning, you just fine tune 0.1% of parameters so that like this fine tuning is much faster. And there are approaches like quantized LoRa where you like further reduces the number of bits used for your adapters so that it's even further smaller. And advantage of these approaches are like more efficient fine tuning. So in normally supervised fine tuning, you mostly provide positive examples, and there's another like reinforcement learning where you provide both positive and negative examples to align the LLM better with like human feedback. And like when ChatGPT came out, the proximal policy optimization technique, which has been around in robotics area since 2017 or so, that basically is one approach. And recently, in last couple of years, there is this Stanford technique developed called direct preference optimization, which removes explicit reward function model, and it's more efficient to do RLHF. And recently, in January, DeepSeek came out with this group relative policy optimization that eliminates the need for this. There is another value model that you normally use in RLHF, like PPO, and so it's a lot more efficient RL technique. So these are kind of different domain adaptation technique in terms of like providing more context through prompt or RAG. If you want LLM to learn how to act in certain way, then supervised fine-tuning and reinforcement learning. So that's kind of things I wanted to cover, and just a couple of thoughts. Like domain adaptation is very important for building enterprise AI agents, and like build agents, not just tools. So with that, I'll conclude my talk. Yeah, I'm happy to answer questions. And yeah, feel free to email me if you have more questions. Yeah, and yeah, we are looking for AI engineers. Anyone interested in working on these things, feel free to email me.